So this is Research Methods Unit 4, Part 3 on validity and control. Now, an important concept that we all need to remember is confounding variables. And this is one of your most common threats to validity, is that there's a confounding variable. Remember the example I always go back to with the ice cream sales and the crime rate. Well, in that situation, you have a confounding variable, temperature, which is actually the thing that's driving the relationship between ice cream sales and crime. So that's an example of a confounding variable, but all studies have the potential for confounding variables. And so technically what you would call a confounding variable is when you have a variable that varies both with the independent variable and the dependent variable, such that there's an influence on both, such as temperature influencing the amount of crime and temperature influencing the amount of ice cream that's sold. So how do we deal with this threat to validity? The answer is that you use control. Control refers to the means by which you rule out certain threats to validity. And there are three types, really. There's experimental, logical, or statistical. So when you're running an experiment, control is often exerted by randomizing subjects. And what I mean here is that if you have a group of people that you want to divide into an experimental and a control group, all you need to do is to bring a coin with you. And if you flip it, and for each person, and if it turns out to be heads, that person goes into the experimental group. And if it turns out to be tails, that person goes into the control group. Because the coin knows nothing about the people that are in your sample, and you have no control over whether the coin ends up heads or tails, this is a good way to make different groups be equivalent to each other. And such that, at the end of the day, when I compare the two groups, it's really the presence of the manipulation, whether it be a drug or some intervention, that can explain the difference between the groups, not the fact that the coin had any reason for putting certain people in one group and other people in another. So imagine that you're interested in exploring the effect of knowing students' names on grading, such that, if I knew people's names, that might influence the degree to which I might favorably or unfavorably evaluate their work. What you could do is to divide the class in half use names and half use a different random number each time for, say, 10 essays they have to write. So one is the experimental group, and one is the control. And what you could do is track these scores across the semester, and at the end, explore whether the relationship between scores on the essays are stronger or weaker in the two groups. So that could be an example of control, so long as I randomly assign each student to be in the name group or the random number group. Now, it's important to understand that experimental control is only feasible when you actually can randomly assign people into groups. So you can't do this when you have a quasi-experimental design. So if you're interested, for instance, on the effect of being a flight attendant or ground crew on cancer rates, you can't randomly assign people to be flight attendants or ground crew because they're different groups of people. Or if you're interested in math performance in males or females, you can't randomly assign people to be a male or a female, or whether they're alcoholic or not, or any other kind of manipulation. It's important to realize that when it's quasi-experimental, that's the huge difference between an experiment and a quasi-experiment, is that in a quasi-experiment you can't experimentally control. So in random assignment, each participant has an equal chance of being in either group, either the experimental or the control. And there are many ways of randomly assigning, and the easiest is a coin, but there's other ways. You can use a random number table, or you can use a computer program to randomize people. It's a very fair, simple way of doing it. Now, another way of controlling is by matching subjects. So instead of randomizing people, what you might want to do is make two groups be more equivalent by making the groups seem as equal as possible on variables that you might think matter. So if you think that gender is an important thing, you might want to have an equal number of males and females in group A and group B. So when you're assigning people to various groups, you might want to make sure that the gender balance is equal. It could be true for any other variable, ethnicity, socioeconomic status, major, but you really should only match when you truly have an idea that the variable that you're matching on, like gender, might have an influence on the dependent variable. So that's one important thing to keep in mind. Now, another thing that you can do is, instead of matching subjects, keep track of various aspects of the subject. So keep track of their gender, keep track of their ethnicity, keep track of their year in college, and you can include that in your analysis later on and see if that makes a difference. Okay, in this situation, you don't really have a suspicion that a particular factor that subjects come into the experiment with, you don't know that it affects the dependent variable, but you think that, it may. So if you record that information, you can later on put that into the analysis as a factor that you want to include. That's called a nuisance variable. But keep in mind that nuisance variables are not necessarily confounding variables, because it may be the case that nuisance variables have no effect on the outcome measure, in which case they're not confounding. A third kind of control is laboratory control. And the idea here is that you do a study in a very constrained situation, for example, in a laboratory, so that you make the setting equal for all people that participate in your study. Now, this is important because what happens here is that you have participants that are tested on the same equipment, by the same experimenter, using the same instructions, maybe at the same time of day. And so by doing this, what you're doing is that, you're eliminating the potential effects of contextual factors. So if I were to do a study and half the people I tested in the cafeteria and half I tested in the library, maybe it's being in the cafeteria with all the noise surrounding you that influences your results. Or, maybe it's the color of the sky if you test people outside. So that's an important reason for laboratory control. But some effects, of course, can't be controlled in the lab. So if you're doing an experiment where you're comparing people cross-culturally, even a lab that's in the US and in, say, Japan might be different. It might be different in size. The computers might be slightly different. The keyboards might be different. So exerting control in these situations can be very difficult and challenging. However, when you're outside of the laboratory, not all, you have to be interested in real-world behaviors. So you might be interested in a variety of things, such as the amount of clothes that people wear, determines the number of sexual advances at a party, smiley faces resulting in a larger tip, or smoking behavior at bars. These are all things that you can't do in the laboratory because they occur naturally outside the lab. Now, in situations like this, you really want to try as best as you can to achieve randomization if you're doing an experiment. So you randomly choose which people at a frat party to study, or randomly give patrons a smiley face or not, or randomly choose 10 bars from Cherry Hill phone book, as opposed to going to 5 on one side and 5 on the other side. But it's sometimes the case that randomization just isn't possible. It's important when you're outside of the lab to use objective rather than subjective measures. So instead of rating on your own kind of scale how happy someone seems, you would rather use something that's more measurable by behavior. So percentage of tip is much more concrete than how friendly you perceived a patron as being. Another thing that you can do is have multiple people rate the behavior. So if you have 2 people observing a particular thing outside of the laboratory and they both agree, you can be more confident in your measure than if it's the case that 2 people don't agree. And again, replication is always important. Conduct your study multiple times, in multiple contexts, and see if the result is consistent.